This is a second recording for section 11.6. We are now going to look at odds. Odds compare the number of favorable outcomes to the number of unfavorable outcomes. Odds are commonly used in horse racing, lotteries, and most other gambling situations. Remember that odds, if you've ever seen horse racing, they say the odds are something like 3 to 2. We usually use this colon. You can also write it as A2B or A colon B. But when the fraction bar is used, it is used to symbolize probability rather than odds. So I would avoid the fraction bar when we were talking about odds. So odds can be thought of the number of possibilities for A colon the number of possibilities of not A. However, you will have to make sure that you reduce it, even though it's written like this. If you have odds like 4 to 2, you do have to kind of think of it as a fraction in order to reduce it. You could divide the 4 by 2 and the 2 by 2 since they have a common factor and write it as 2 to 1 rather than 4 to 2. So you will have to reduce the odds. If the odds in favor of event okay, yeah, I guess that's fine. You don't need to cross that out. If the odds in favor of an event are A to B, then the odds against the event are B to A. And I already mentioned that before. Odds are reduced. If it's 2 to 4, it should be reduced to 1 to 2. And the order that you write it is very important because 4 to 1 odds are there's a very good chance of winning. But 1 to 4 odds is not a very good chance of winning, right? So you have to write it the appropriate way. Let's compare probability and odds. If there are 4 red marbles and 3 blue marbles, find the probability a randomly selected marble is red. So we know there's a total of 7. When we talk about probability, we say how many in the event over the total number. So there's 4 red marbles out of 7. This is the total. Odds, you don't do that. The odds of selecting a red are there are 4 red, there are 3 not red. So you can see you're not putting the total 7 in your odds. It's how many are red, colon, how many are not red. And 4 and 3 don't have a common factor, so that is reduced. A random card is drawn. What are the odds of drawing a spade? So again, we want the number of spades, colon, the number of not spades. Okay. Of non-spade cards. So we do not mess around with the 52 like we do with probability. There are 13 spades, and then you have to figure out how many are not spades. Well, there's 52 total minus 13. That should give you 39. So there's 39 cards that are not spades. But notice that these two will total the probability, like that last one. 3 and 4 make 7, right, which is the total. So those two should total the denominator in a probability in a sense. But this actually, so the odds are 13 to 39, but you should reduce them, right, because 13 goes into both. So 13 goes into 13 one time, 13 goes into 39 3 times. So the odds of drawing a spade are 1 to 3. And therefore, the odds of not drawing a spade would be 3 to 1. Right? You have a good chance of not drawing a spade. 200 tickets were sold for a drawing to win a TV. If Matt purchased 10 of the tickets, what are the odds in favor of Matt's winning the TV? So the number of winning tickets over colon not winning. There's a total of 200 tickets. 10 of them are winning tickets for him, there's 190 that are not winning tickets. And then, of course, you can reduce that. They should total, right, 10 and 190, they should total the denominator in a probability event, right? But these are both end in 0, so you can divide them both by 10. 10 divided by 10 is 1. 190 divided by 10 is 19. So the odds in favor of Matt winning the TV is 1 to 19. So we should be able to convert between odds and probability. First, we will go from odds to probability. If the odds in favor of event E are A to B, then the probability of the event is given by the probability of event E is A over A plus B. So the odds in favor of a particular horse winning a race are 2 to 5. What is the probability that this horse will win? All right, the odds are 2 to 5, so it's 2 over 7. All right, it's event A, or it's A over A plus B, which we knew that if it's 2 to 5, the odds are less than 50%, and 2 over 7, 2 out of 7 parts is definitely less than 50%. What is the probability it will not win? 2/7 plus 5/7 will give you 7/7. So we know it's 5 out of 7. Or you would do 5 over 5 plus 2. 5/7. But we know that these total 7/7. So that is how you go from odds to probability. Remember the 2 to 5, when you sum them up, that is the denominator for the probability. Probability to odds. If the probability of rain today is 3/8, what are the odds of rain? So this is the total is 8. 3 to 5. Right? Remember, if you add these together, you get the denominator, 8. Here, if the odds of rain are 0.43, right, or the probability is 0.43, what are the odds? It's 43% for rain, so it must be 57% not rain, right? They have to total 1. And then I wouldn't give decimals, 43 to 57. And those, of course, are reduced. Which is what you would think of when you think of 0.43. It's 43%. So it's 43% it does rain, and 57% it doesn't rain. That is the end of section 11.6.